list the sides in order from smallest to largest. So before we start listing them, because we do have 98, which we know that this will more than likely be the largest side, right? So we can say K to M would be the largest side. We need to figure out that other angle so we can identify the correct shortest side or smallest side. What would be the missing angle? 98 plus 24? 58. So if this would be 58, what would be the smallest side?
M to L.
M to L. Remember, go directly across. Your smallest side would be M to L. So then the side that I guess we would consider the middling side would be K to L. All right, so go ahead and put the warm up to the side, and then we'll go on with today's notes. All right, so we're looking at the triangle inequality theorem. When we're deciding if three sides or three measurements make a triangle, we need to make sure that every two sides are greater than the third side. And because there's three different arrangements, we have to do this 3 times. So it's color coded up there, right? It says the red one plus the blue one has to be greater than the green one. The blue and the green must be greater than the red. The green and the red must be greater than the blue. If you notice, at some point, each side was by itself on the right side. So you have to add 2, always compare it to the third one. So we have 3 measurements here, or 3 links here. It says, is it possible to form a triangle with the given side links? If not, explain why. All right, so all we're gonna do is we're gonna take, I always write it in order, exactly the way it looks. So I'm gonna do 8 plus 15 is greater than 17. And then I always write it backward, just to kind of show you my process is greater than 8. All right, so the numbers going forward, the numbers coming backward. And then I always do the last 2. I always look at these last 2 and I'm like, okay, now I'm gonna do 17 and 8. I'm gonna do 17 plus 8. And that has to be greater than the only number that's not on the right side, which is 15. So if you notice, each number at some point is on the right side to compare to. All right, and then we can do mental math if we want to, right? We can do 8 plus 15. Is that gonna be greater than 17?
Yes.
It should be, right? Because 15 is only 2 units smaller than 7. So if I'm adding 8 to that, that's definitely going to be greater. And if it is, you can just check it off. All right, 17 plus 15, is that greater than 8?
Yes.
Yes, automatically they're already greater than 8 to begin with. And what about 17 plus 8? Yes or no? Yes, so then you would say, yes, we have a triangle. Now we will get to then classifying the type of triangles, not today, but we will, so we will see this process again. All right, and then we'll do the same thing on the next one. So we're going to go forward. And we're going to write the same statement, but we're going to go backward with our numbers. And again, always take the last 2, the 30 and the 15, and we're going to put those together. 30 plus 15 is greater than 16. All right, now we just add and compare. 15 plus 16,
31.
is it greater than 30?
Yes.
Yes. 30 plus 16, is that greater than 15?
Yes.
30 plus 15, is that greater than 16?
Yes.
Good, so is this one a triangle?
Yes.
All right, you would just put, yes, we have a triangle. All right. All right, now you're gonna do the same thing. Now what you wanna do on letter B is just enter that in your calculator. Can someone enter that in the calculator? Just enter 2 square root of 5, exactly the way that it looks. So put 2 first, and then the square root of 5. Give me the decimal, just give it to me to the 10th place. What would it be? 4.47, so we'll do 4.5, right?
Yeah.
And what's the square root of 17? That'd be 4 point something. 4.12, so 4.1. All right, so just use the decimals. Just use the decimals when you're comparing here, okay? All right, let's check that first one. So on the first one, we're gonna add those going forward, right? So we have 6 plus 18. Is that greater than 14? Was that true?
Yes.
Okay. 14 plus 18, is that greater than 6?
Yes.
And then 6 plus 14, is that greater than 18?
Yes.
Yes, all right, so this one should have been yes, this one's a triangle. All right, look at the next one. 4.5 plus 4.1, is that greater than 8? Yes. And we go backward, bless you. 8 plus 4.1, is that greater than 4.5?
Yes.
Mm-hmm. And then the last one, 8 plus 4.5, is that greater than
Yes.
4.1. Yes. All right. I'm going to have you guys add an extra down there at the bottom. I know you have space. Let's do 1, 2, and 3. We'll call this letter C. Okay. So this is one where if I add them, and this will happen, I just didn't have one on here. Don't know why I didn't have one on here. 1 plus 2, is it greater than 3? No. It's equal. So is it greater? No. So the moment you, because hopefully you do one line by line, right? I just kind of showed you the setup right away, so you knew how I was going to set it up. But I would do a line for line, because the moment you hit that 1 is not true, you would just write not a triangle. And your explanation would just be that 3, I'm going to write it over here, that 3 is not greater than 3. So you just show me the numbers. Just show me the numbers that proved that weren't true. All right, so if you come across one that's not true, that's all you're going to do. All right, all we're going to do on the right side is just in terms of a word problem. It's the same thing. So on the right side, it says, if the measure of two sides of a triangle are 3 feet and 7 feet, what is the range? So just a word problem. If you notice, you have 3x and 7. It's just a word problem. If you notice at the top, they're all set up the same way. All right, you just solve it. Solve it as if you were solving for x. What's 3 plus 7? 10. 10 is greater than x. There's nothing else to do, so you're done. All right, look at the next one. What should I do here? Add the 3? Minus the 3. All right, let's minus the 3. 7 minus 3 is? 4. And then you're done with that one, right? There's nothing else you can do with these. All right, do the next one. Let's minus 7. Minus 7, minus 7. X has to be greater than negative 4. All right, so you have 3 answers. If you notice, there are 2 smaller numbers and then 1 big number. The big number is obviously the one that has to be true because it's the only big number. It's also the only one that's true because it's the only one where x is less than. Do you see how it says x is less than? This one is saying x is greater than, and this one is also saying x is greater than. So when it says x is less than, this is going to be your maximum number. You're going to put a 10 here on the right side. You have to decide which minimum you're going to use. So for now, this one's going to be a little obvious, but when we get to the other expressions where all the sides are going to have expressions, it's going to be a little bit more, we have to think just a little bit more. So if I put a negative 4 here, could I have a negative 4 measurement? No. What if I just put 4 here? Could I have a 4-foot measurement? You can have a 4-foot, right? Just not a negative 4. So you're never going to do the negative when it's just an x, okay? You're going to always take the positive. Now, if you read this carefully, you read it as 4 is less than x, which is less than 10. You can also read the same statement as x has to be between 4 and 10. That's the easiest way to read it. X has to be between 4 and 10. Can it be 4, though? Can it be 10? No. Okay, so the next question says, which of the following cannot be a possible side length? Well, we already said it can't be 4 and it can't be 10, right? Which ones cannot be? What else can it not be? Can it be 5? Can it be 6, 7, 8, and 9, right? It could be all those. It just can't be 4 and it can't be 10. Could it be 11? No, because it's not in between. All right, so I'm going to have you guys do the same thing with practice 2. You're going to set up all 3, solve all 3, and then from there, decide your range. So I'm going to tell you now, your range is going to look just like it did above. You're going to have x in the middle, a minimum, and a maximum. All right, hopefully we have 6 plus 18 is greater than x as one of them. Bless you. X plus 18 is greater than 6. And then the last one being 6 plus 18 has to be greater than, I already did that one. Which one am I missing? 6 plus x has to be greater than 18. All right, on the first one, what was 6 plus 18? 24. 24 must be greater than x. What's the next one?
Negative 12.
X has to be greater than negative 12. And the last one is x has to be greater than 12. Are you going to ever take the negative for now? No, not when it's as simple as this. So don't take the negative. You take the small one. You take the large one. X has to be between 12 and 24. All right, which ones cannot be a possible measurement for that third side?
3.
It can't be 3. 10 and 6?
24.
24. Could it be 20?
Yes.
18, and then 15. Good. All right, so the only way it's changing, class, it's the same process. It's just longer expression. So if you notice on this one, we do have x plus 2. So we're going to just do the same thing. You're going to take x plus 2 plus 18 has to be greater than the third side, which is 10. And then come backward. So with this one, I would set them all up first, just to make sure you have them all. So 10 plus 18 has to be greater than x plus 2. And then the last one being those 2 would be 10 plus x plus 2 must be greater than 18. All right, so this is just solving for x, right? What's 18 plus 2? 20. What's x plus 20? X plus 20 must be greater than 10. Sorry, I wanted to write in red. X plus 20 must be greater than 10. We subtract the 20, right, minus the 20. So x must be greater than negative 10. All right, do the next one. 10 plus 18 is 28. Good. Subtract the 2, and what do we get? 26 has to be greater than x. And then we do the last one. 10 plus 2 is 12. Minus the 12, and x has to be greater than 6. You can try the negative if you want first, just to see if it's a possibility. Like if it has to be greater than negative 10, what would be the next number that would be a possibility but it's closest to negative 10? Negative 9. So if I plug in negative 9 here, if I do negative 9 plus 2, is that possible? What's negative 9 plus 2? Negative 7. Could this be a length of negative 7? No, so don't get your negative. So just do a quick check. Say, okay, that doesn't work. Put your x. Put your smallest number first. What's our smallest number? Our greatest number is 26, and then you're done. All right. If we look at the last one, just if you want to flip over the last one real quick. At the bottom, I'm going to show you just what it'll look like on some problems. But on this one, it's the same thing. So we're going to take the first one. We're going to do x plus 11 plus 2x plus 10 has to be greater than 5x minus 9. Right? And like this is a side and that's a side. Just so we know like what we've already put together. All right. What would be another equation I could use? Five x minus 9 plus what?
2x plus 10.
2x plus 10 must be greater than x plus 11. All right. So then we know these are two equations, right? So then what would be the last set of equations I could use? Or last setup I can do? You can take the last two pieces. What are the two equations on the right side? We have the 5x minus 9 plus x plus 11 must be greater than 2x plus 10. All right, let me give you a moment to solve those. All right, what did you get for that first one? First one? Aiden? Work it out for me. All right, you can work this out. What is it?
Okay, so left side,
Mm-hmm.
It's going to be 21 and 3x.
21 plus 3x.
Yeah, that's going to be greater than 5x minus 9.
Good, and then?
And you go from the x, so it's minus 3x. So the left side, or the right side will have 2x minus 9.
Mm-hmm.
And then plus 9.
Mm-hmm.
So it's going to be 30 is greater than 2x.
Good. So then what am I going to have for my final answer?
15 could divide by 2.
Uh-huh. Is what?
Greater than
Greater than x. Good. All right, let's try the blue one. Jackie, do the blue one for us. It's okay. What's 5 plus 2? 7x. Good. What about negative 9 plus 10? Plus 1. Good. And then x plus 11. All right. So let's minus the small x. What do I get when I minus the small x? 6x. And then when I subtract the 1, what do I get? 10. So then x has to be greater than 10 over 6, right? And that simplifies to what? 5 over 3, which would be about 1.6 1.667 rounded, right? And it's okay to get a decimal. You might get 2 decimals, and you still have to determine which one's going to work. All right, Will, go and do that last one for me, Will. And what do we get?
6x plus 2.
Is greater than?
2x plus 2.
Good. And then what else do we get?
Get rid of the 2x.
Mm-hmm.
So 4x plus 2 greater than 10.
Good.
And then subtract the 2.
And what does that get us?
4x greater than
8. Good. So then x has to be greater than 2. Okay, so if you notice on this one, there were no decimals. They were all positive numbers. All right, this is where you're gonna have to do just one small step. You guys, it's a very simple step. All right, so which one do we know for sure has to be part of our solution? The 15, right? 15 has to be part of it. The question is, like, we know that's gonna work. The question is, should I use the decimal or should I use the 2? So what you're gonna do is you're gonna do the number that go up one number, one whole unit that's greater than 1.667. What would be the next unit greater than? 2. Okay, 2 would be greater than our decimal, right? Would 2 be greater than 2? No. Okay, then try the next one. Pick a number greater than 2. What do we have? 3. Is 3 greater than 2? Good. Is 3 greater than our decimal? Yes. So then that's the one that works for both. So you're going to pick the one that works for both. All right, even if you're having 2 numbers that are both big, like you're deciding between the greater than and for the maximum, pick the one that works for both scenarios. All right, and then the last thing. This one says, determine if it's possible to create a triangle with the given side lengths. If so, order the angles in order from largest to smallest. So what are my 3 letters that should be surrounding my triangle? What's the name of our triangle here? D, E, F. Doesn't matter where you put them at. Just mark one D, one E, and one F. It's okay if yours was in a different order. Between D and E, we're going to write 3 square root of 5. Between F and D, we're going to put the square root of 48. And then between F and E, we have 2 square root of 37. Now, first it says, determine if it even makes a triangle. Now, we just sketched it assuming it was going to be one, but let's make sure it does create one. All right, so let's go ahead and do the square root of 48. Can someone give me the square root of 48 rounded to the 10th place? Square root of 48? 6.9. All right, so this is going to be about 6.9, so I'm just going to write 6.9 there. What about 2 square root of 37? 2 and the square root of 37. 12.2. All right, and what about 3 and the square root of 5? 6.7. All right, so just do your decimals. Let's do 6.7 plus 6.9 is greater than 12.12. Is that true? Kids, and I know we're giggling at the 6 and 7, but I'm asking a question. Is 6.7 plus 6.9, is it greater than 12.2? Yes. It is, right? So let's check the other one. Let's go 12.2 plus 6.9. Is that greater than 6.7? It should be, because 6.9 is already greater than. All right, and then we try the last one. 12.2 plus 6.7, is that greater than 6.9? Yes. And that one should be. So do we have a triangle? Yes. Okay, so you're going to say, yes, you have a triangle. So now you answered the first part. Next one says, if so, order the angles in order from largest to smallest. What would be your largest angle here? Which would be angle D, followed by angle. Ooh, which one's greater, 6.9 or 6.7?
6.9.
6.9, so it should be the 6.9. All right, and then go across. That one should be E. And then our smallest angle should be angle F. So that would be your second answer.